The title of this paper is Unregistered Multiview Mammogram Analysis with Pre-trained Deep Learning Models. This is a joint work between the University of Adelaide, the IST from Lisbon, and the University of Queensland. This work is supported by the Australian Research Council. In this paper, we are concerned with two research questions. The first question is, can we use convolutional neural net models pre-trained with computer vision databases in medical image analysis? This would be important to allow the use of CNN in medical image analysis problems with small annotated training sets, which is usually the case. For example, we can take ImageNet, which is a database used in computer vision that contains millions of images, and use it to train a convolutional neural net, which usually needs very, very large databases to be robustly trained. Then we can take a database of medical images, for example, mammograms like here, and use them to retrain the same convolutional neural net that has been trained before. The second research question is, can high-level CNN features be used in multi-view classification without pre-registered input images? For example, again in the case of mammograms, can we take images from CC-view and MLO-view and extract the high-level features using a convolutional neural net, for them using these high-level CNN features to do the classification of the mammogram? In answering these questions, we propose this new model that is able to analyze mammograms from 6 different views, as you can see here. We take the actual mammogram images from the CC view and the MLO view, and then we take the microcalcification masks from both views and also the mass masks from both views. And then we extract the high-level features of each one of these views using a CNN that's pre-trained with ImageNet. And finally, taking the high-level features from each one of these views, we train another CNN that will assess the patient's risk of developing breast cancer. Notice that the views here are unregistered and the CNN is pre-trained with ImageNet. For the single view convolutional neural net, we follow the same scheme that has been used to train these models for ImageNet. So basically, we actually take a model that has been trained before and use it here to retrain each one of these 6 views. Specifically, this model will have a certain number of stages containing convolutional and nonlinear subsampling layers, followed by a number of stages containing fully connected layers, and finally, a last stage containing the classification, which is a multinomial logistic regression. And then the multi-view convolutional neural network is just a very simple network that put together the high-level features of each one of the 6 views, and it's fine-tuned specifically for the mammogram dataset. We assess the performance of our model using the volume under RC curve for the 3-class classification of mammograms, where the classes are negative, benign, and malignant. In general, the VUC results show that the multi-view classification is significantly better than the classification of single views. Notice, for instance, the black curve in the graph produces a much higher VUC result compared to the results of the single view. This shows that the multi-view analysis of the unregistered views is effective. It's also easy to see that the model pre-trained with ImageNet on the left achieves better results than the model trained from scratch on the right, showing that the pre-training process is actually important in this process. Finally, these are some results produced by our system. In general, negative results are easy to detect, but the differentiation between benign and malignant is quite challenging, as can be seen by these 3 cases. In conclusion, unregistered multi-view analysis is effective with our CNN model. Pre-trained models are better than models trained from scratch, and results are comparable or better than the state of the art.